Okay, hey guys, this is the check your work video for lesson 19 where we're solving, adding, and subtracting equations. So remember, we want to really focus on what operation is being performed in the original equation, and then focusing on how do we do the opposite of that operation. So the inverse of subtraction is addition, and the inverse of addition is subtraction. They're opposites. So if you see a problem that's showing subtraction and you want to get the variable by itself, you need to add. If it's showing a variable with addition, then you need to subtract to get the variable by itself. Hopefully that helps you kind of just make your brain go into that pattern of thinking, okay, what operation is being shown? What's the opposite of that operation? And then you do it. Okay. So we're going to be looking at 8, 9, and 10 together today. Hopefully you are looking at this video after you have already tried to do the work on your own. Let's look at number 8 first. I'm going to be doing each of these in a different color to make it a little bit easier for you to follow along. The first one we're going to be doing in blue, or like an aqua. Tim said that to solve the equation x minus 2 equals 9, he would need to subtract 2 from both sides of the equation. Is Tim correct? Explain. So when we look at this problem, this is already subtraction. Is subtraction the opposite of subtraction? Well, no. The opposite of subtraction would be addition. So you would add 2 to both sides. So Tim is not correct because you would need to add because it's already subtracting. You want to do the opposite. He is correct, though, that you need to do it on both sides of the equation. So you would say, no, Tim is not correct because he needs to add 2 to both sides, not subtract. The opposite of subtraction is addition. Okay. Let me change my color out. Do orange for 9. Write the equations described below. An addition equation with one variable that has a solution of 3. So here's where you guys might get confused. This doesn't mean that the equation itself equals 3. It means that your variable should equal 3. So you could do something really simple like x. Remember, it's addition, so plus 2, and then we would go, what's 3? Because we're putting 3 here. Plus 2, 5. Simple enough. So an addition equation with one variable, we've got our one variable, it's addition, that has a solution of 3. So if I wanted to make sure this equaled 3, I would do the opposite of addition, which is subtraction. So 2 minus 2 is 0. 5 minus 2 would be 3. Okay, it has a solution of 3. Let's look at B. A subtraction equation with one variable that has a solution of 2/3. A lot of times when you guys see those pesky fractions, you tend to flip out and not even try to do it. So I'm sure that a lot of you are going to be coming and looking at like, wait, how do you do this one? So it's pretty much the same as this, except that instead of addition, you're going to be subtracting. So I'm going to use a different variable just so that we don't get confused by the variable up there. I use b, and I have to subtract something. And I can make this really easy. B minus 1/3. If b is supposed to be 2/3 and I take 1/3 away, what's going to be left? 1/3. You can make it more complicated than that. You don't need to, but you could. So if I want to make sure that b is actually 2/3, I would add 1/3 to both sides. So negative 1/3 plus 1/3 would be 0. 1/3 plus 1/3, well, 1 plus 1 is 2. You keep the denominators the same, so it'd be 2/3. So b is, in fact, 2/3. Then we look down here at number 10. Let me change my pen. Hey, that rhymed. 10 is going to be in this color, which is like a darker blue. Marge said that she subtracted 20 from both sides of an equation to solve it. So she subtracted 20 from both sides. So that tells us that the original problem should have adding 20 to both sides. Sorry, not adding 20 to both sides, but it should have an addition of 20. Colin thinks that the equation she was solving could have been 6 plus t equals 20. Does Colin's reasoning make sense? Explain. So it is an addition problem, so he's got that going for him. He is right that it would have to be an addition problem because Marge subtracted 20. So that means that it had to have been an addition problem. So that's right. Colin's right in that sense. Yes, Colin, it is an addition problem. But that's where he stops being logical. So this is an addition problem and it does have a 20. But this 20 is not attached to a variable. What number is attached to the variable? 6. So if this had been the equation Marge had solved, she would have been subtracting 6 from both sides, not 20. So Colin's reasoning makes sense in the fact that he knows that it's addition, but it could not have been this equation because the 20 is on the opposite side of the equation. Remember that we do the inverse operation. We do the opposite of addition. We subtract to get the variable by itself. So if this 20 is already over on this side, it's already away from the t. It's already away from the variable. There's no reason to add it to both sides. Or sorry, to subtract it from both sides. You would subtract the 6 from both sides to get t by itself. So that's what you would have to explain down here, is that Colin is right. It does have to be an addition problem or an addition equation because she subtracted, so you had to do the opposite. But it would be more like t plus 20 equals 6, because that 20 would have to be with the variable. With it written this way, this means that 6 would be what you're subtracting, not 20. Hope this video helped. Make sure you are giving yourselves time to relax, not just do all this work in one day. I really hope you guys are either sticking to the schedule or at least just doing a little bit each day and not overwhelming yourselves on one day where you try to get it all done. Because I'm seeing a lot of you guys turning in like multiple assignments on one day, and I'm kind of like, oh man. I mean, if that works for you, that works for you, but it could get pretty stressful if you do that all the time. Anyway, take care.